Hello, this is Jennifer Martinez. This video is on similar triangles. What is a similar triangle? Similar triangles are triangles that have the same shape, but not necessarily the same size. So if I draw a triangle, so here's my triangle, move it up a little, and I enlarge it or shrink it. I just made a copy of it right now. So these actually are still similar. They're called congruent because they're exactly the same thing. But if I actually stretch it or shrink it, these would be similar triangles. Right now I just made a copy of it. These two triangles are actually congruent. They're also similar, but they're congruent because they're exactly the same size and shape. But if I enlarge it or shrink it, we shrink it, these are two similar triangles, or enlarge it, either one. Those are all similar triangles. Let's go ahead and enlarge it. There are conditions for similar triangles. Triangle ABC is similar to DEF, so let me go ahead and label them. So I'm just labeling this ABC. Notice if I decide this to be A, then this is the corresponding A and D, B and E are corresponding, and C and F. So the corresponding angles have the same measure. So A has the same measure as D, and B has the same measure as E. How I wrote them there, the second and the second, and the two last, they would have the same measure as well. And that signifies that they have the same measure. Also, the corresponding sides are proportional. So if I label this small a across from the big A, the angle A, across from the angle B, I'll label it small b, and so forth. The same with this, E, F, and D. Then it turns out that, for instance, B over E, you can have all kinds, is equal to, so we have the small to the large is the small to that corresponding to the large to that. And also, you can say the same thing to the bottom ones here. This ratio, it's also equal to C over F. So it says the corresponding sides are proportional. What does that mean? That means the ratios of the corresponding sides are equal. So let's look at example 4. So you can see the example 4 is similar. They're two different shapes, but they do have the same angles. So we want to find the lengths of these unknowns. So I'm just going to call this little d, and I'm going to call this little e. We don't have to label those because they're known. And we can say that, I'm just going to start with small to large equals, so we have 8 to 16 because these are corresponding, so we have d over 32. And then you can actually solve this. You could reduce, you don't have to, but you could reduce this first if you want to make the numbers a little smaller from you. And then we've learned in algebra that when two ratios are equal to each other, you can multiply 2d equals 32, the 2 and the d, and then you can multiply the 1 and the 32, and they're equal to each other. So you can get the answer for d is 16. So I added this note here. If a over b in general equals c over d, then that means that AD better equal BC. You can also solve this by multiplying both sides by the LCD. To find E, I'm going to do the same thing. I'm going to take that 8 over 16, and instead I'm going to now look again the small to large. I'm putting the small in the numerator, so it better be E in the denominator, and 24. So again, 1/2 is, I'm going to change that 8/16 to 1/2, and then I'm going to say that 2e equals 24, or e equals 12. Now you could do any ratio. I could have done large over small, right? So I could have said 24 over e. And then if that was the case, I would get 32. I'll use this one instead of the 8/16. 32 over d. Oh, d we found was 16, which is why I didn't use that one in the first place. But this one would work as well, because this would be 24 over e equals 2 over 1. And look at, you get the same thing. 2e equals 24. So you can see that you can use any ratio. You could even go for 16 over 24 equals 8 over e. So any ratio will do. Let's try that one. I'll do it over here. 16 over 24 equals 8 over e. Let's see if that works. Well, then we have here, we reduce this. 8 goes into both those, so this would be 2/3. And then we would have 2e equals 24. It's still 12. So you can see here, there's 3 methods that I chose, that it doesn't matter. All corresponding sides are proportional. So let's look at an application of this. We're going to find the height of a flagpole. Workers must measure the height of a flagpole. They find that at an instant when the shadow of a building is 8 meters long, the shadow of a flagpole is 27 meters long. The building is 10 meters high. Find the height of a flagpole. So here's my building and here's my flagpole. I know the building is smaller than the flagpole because it says that the shadow of the building is 18 meters long, where the shadow of the flagpole is 27. So I'm going to draw a shadow on the flagpole and make that shadow 27 meters long. And it says that the instant when the shadow of the building is 18 meters long, the shadow of the flagpole is 27. So I realize I'm going to have similar triangles, because if I actually moved the building, maybe it would have been easier to move the flagpole. I don't know if that's proportionally correct. It's going to, the sun is going to hit this corner and form this the same angle there. So they're going to be 2 similar triangles. And the shadow, whoops, I should connect that. And the shadow of the building is 18 meters long. That's from there to there. So you can see you have the bigger triangle within the smaller, and they are similar because these angles are the same and these angles are the same. We also know that the height of the building is 10 meters high. So if I just make this 10 meters right there, and we want to know the height of the flagpole. So I'll just call that x. So we can come up with many proportions, but let's start with building, right? Building to flagpole. Okay, so if I do that, let's talk about the building, the heights. So the building is 10 and the flagpole is x. The shadows, the building is 18 and the shadow is 27. And we get ourselves a proportion. You didn't have to choose this ratio. You could choose any ratio as long as you're careful to make them the corresponding sides. Notice how I did not make the 27 over 18 here. That wouldn't work. So if it's the building on top of the flagpole, the building, the shadow must be on the numerator as well, and vice versa. So you could have said flagpole to building. So let's go ahead, and I guess we could reduce this. 9 goes into both of those, so 9 goes into 18 2/3. So then I can then cross multiply these, and it's equal to the 30. So it looks like the flagpole is 15 meters. If you want to see the picture that they have in the book, maybe a nicer picture separated, here it is on the bottom. So there's the building that's 10 feet in the shadow. Here's the shadow of the flagpole. In the same instant, we know these angles must be the same. So here is my triangle for the small one, and here's the triangle for the large. We know this angle must be the same as this, and therefore, and this angle is the same as that. Therefore, those two angles are going to be the same as well. That does it. Hope that helps.